Number 19. A wave with a wavelength of 50 centimeters is traveling on a string. The graph below shows position as a function of time for a point on the string. If the frequency of the wave is cut to half, what's the average speed of the point? All right, so we can look at this and say, okay, so the wave is starting here, and it's traveling one wavelength in a half a second, and it's traveling two wavelengths in 1 second. All right, so let's get our frequency. Our frequency is the number of cycles per second. So it's doing two wavelengths or two cycles in 1 second, which is a frequency of 2 hertz. All right. So now to get its speed, we can say, okay, speed equals distance over time. So the distance that the point is traveling, remember the points just travel up and down. The energy is transmitted along the wave, but the points on the wave just travel up and down, right? So now, initially it's going to travel up 0.8 meters, down 0.8, down 0.8, up 0.8, up 0.8, down 0.8, down 0.8, up 0.8. So it's going to do a distance of 0.8 times 8 times over a time of 1. So that's going to be 6.4 meters per second. So if we cut the frequency in half, that means instead of 2 hertz, let's cut it in half. So that would be 1 hertz. All right, let's erase some of this. What 1 hertz means, instead of doing 2 cycles in 1 second, we're only going to do 1 cycle in 1 second, right? So 1 cycle would take us from this point to this point to this point, and it's not in a half a second. This is going to take 1 second now, all right? So our new speed is going to be equal to the same amplitude, but instead of going 8 trips up and down, we're only going 4, which is going to be 3.2 meters per second, which is closest to 3.6 meters per second.